Okay, so I got my mic and I'm ready to go. So I'm recording this just in case y'all aren't here to see these notes if you're absent or have some kind of obligation. I wanted to make sure that you had a way to see the notes that we're going through in class today. So, to introduce it, throughout this unit, if you don't remember, we've been talking about natural selection. We talked about Darwin. We talked about the process of natural selection, how over time certain traits or adaptations that are better fit for their environment will enable reproduce more, and after a while that will be the most common trait because it's the best thing you got. So we're going to expound upon what Darwin taught, and we're going to learn specifically about species and how they come about. So here we go. Oops. So Darwin did come up with the idea of natural selection, but he never explained how these different species, how these traits that can create different species come about. And he has some quotes from him there. But I have good news. Today we're going to find out how new species come about. So let's start with what a species is. So if you don't know this, you know now. A species was defined by this guy called Ernest Mayr. He decided the species had two things that made it work. Number one, members of that population, they can interbreed and produce offspring that can also interbreed. You hear in the PowerPoint, we use the words viable and fertile. They also have offspring that are reproductively compatible. So, for instance, human beings. All human beings can reproduce with each other. They are reproductively compatible. They may not choose to, but they can. And 99% of the time, without complications, offspring of humans can reproduce with other humans. But, for example, the eastern and western meadowlark, they look really similar. And they're both birds, so you might think to yourself, man, they can reproduce. But they're actually distinct species because they mate or they attract mates using songs, and their songs are different enough to where if an eastern meadowlark hears the mating call song of a western meadowlark, it's not going to go for it because it's like, that's not what I want. So let me go ahead and clear a roadblock that as a middle schooler I found myself hitting a lot with this concept. When we say that a species can interbreed, or we decide that a species, two birds or two whatever, aren't a species because they can't interbreed, it doesn't just have to be a thing of their sperm and egg work together. Yeah, they're both birds, and if we were able to force their sperm and egg together in a controlled environment, yeah, it'd probably work. But you have to remember, in nature, there are more barriers to reproductive compatibility than just do the sperm and egg work together or do things work. So there are, and we're going to learn about those limitations today. Like with these birds, their limitation of why they're different species doesn't have to do with their sperm and egg. It has to do with their way they communicate. So go ahead and clear that out in your mind and think, okay, the interbreeding does not just can they interbreed doesn't just have to mean their sperm and egg work together. There are other factors that can stop two species in nature from interbreeding. Let's find out why. So, how do they come about? So, as we've learned, in populations you can have things like mutations or gene pool changes that cause certain adaptations to come about, and they become better and are naturally selected for, right? But let's say that populations become isolated. Maybe they get broken apart by a canyon, maybe a river splits in half, etc. If they're separated by a big gap, in this instance like the fish, they're reproductively isolated. So since we know mutations are random and the gene pool has changed, a mutation could happen in the left pond, like down here you see the blue fish, that doesn't happen in the right pond. The blue mutation obviously helps it blend in the left pond, so over time that blue becomes more common. So it gets to a point where that since they're evolving independently and they can't reproduce because they're separated, they are now different species because one is all this new color and all this new gene pool that the other one doesn't have, and they probably wouldn't mate together. And we could probably force a sperm and egg together, but in nature, there's no way for them to interbreed, and they probably wouldn't if they got together because they're too different. So that's one example. So there are two kinds of isolation you need to know about today, though, that keep us from interbreeding. There's allopatric, which is geographic separation, like those fish. You can get separated by a barrier, and guess what? You're not reproducing. because you're separated. And you can have what's called sympatric. When you think sim, think similar. Think similar or the same. So in a sympatric area, in a sympatric isolation, they're still together, but there's something separating them externally, like those meadowlarks. They live in similar areas sometimes, but because they have different songs, they're not gonna. A eastern meadowlark is not gonna mate with a western meadowlark that has a different song. So there are things that isolate them beyond just sperm and egg or things like that. So there are two kinds of barriers. There's pre-reproduction and post-reproduction. I think y'all know what pre and post means. Cross my fingers. So if it is a pre-reproduction barrier, it means it's stopping the mating or fertilization from ever happening. This can be a geographic, where they get separated by something like the mountain. It could be ecological, like they have different habitats, like that one likes trees, that one likes ground. It could be temporal. Temporal means time. So they could mate at different times a year. If you're not awake to mate, guess what? You ain't mating. Could be behavioral, like those birds. They have different songs. They're not going to communicate well together. It can be mechanical. All I'm going to say for this is a square peg does not fit in a circle hole. That's all you need to know. You can fill in the gaps. Or it could be a gamete isolation, like when if a sperm does get to the egg, it goes, nah, bud, this ain't going to work. So those are some pre-barriers. We'll start with geographic isolation. So this is where the species occur in different areas. There's a physical barrier, or they're separated. They're almost in two different countries. For example, these two little squirrels here, they look really similar. But guess what? One is on the south rim of this canyon, and a few miles away across the giant canyon is the other one. So they're closely related, but since they are separated, obviously they can't get to one another. So over time, so that keeps them from mating. So over time, since mutations are random, right, and they've evolved separately each other, the antelope, the Harris's antelope squirrel, has developed traits or adaptations that are different than those of the white-tailed antelope squirrel. So since they are separated and over time have evolved such different traits or traits that make them special, they're now different species because they don't have any way to reproduce, and they won't because they've become too different. So, talk about ecological isolation. It's where this is that sympatric speciation we talked about, where the two are in the same region, but they're in different habitats. So they're not really going to run into each other much. So they can't reproduce because they have different habitats. So they're different species. For example, there's two species of gar snake. I'm going to screw this name up, the Thendophis. There's two species of gar snake called the Thendophis. I got this. So they occur in the same area, right? But one lives in the water and one is terrestrial on land. Land animals, well, except for us, we're weird. Land animals ain't going to swim over into the water to mate. That's not how it works. Like, I ain't going in there. And the water one's like, I live in the water. I'm not coming out of there. So they both are super different. They both are better adapted to their environments. One's adapted to the water, one's adapted to land. So since they have super different habitats and they won't intermingle and they don't reproduce, that makes them different species because they have that big difference and they won't ever make fertile offspring in nature. Key thing is that there is in nature. Because y'all know humans, we can force genes together. We can make them interbreed, but in nature they won't. That makes them different species. Lions and tigers, for example, they live in different habitats. We can hybridize them because, we can force them together. If you've seen Napoleon Dynamite, you probably heard of Tulager, So we can force them together, but in nature. One lives in grasslands, one lives in rainforests, so they ain't going to run into each other. They're not going to interbreed in nature. So they are different species. And I mean physically, they look a little different too. Makes sense. Temporal isolation. These are species that are going to breed either during different times of day, during different seasons, or during different years. They can't mix gametes. I mean, think about it, right? If you're a bear and you hibernate, if you ain't awake in the winter, guess what? You ain't going to mate with nothing because you're sleeping. Don't wake me up, or don't wake it up. And the bear's like, get away from me, I don't care. So, this is another form of reproductive isolation. If you're not there or awake to mate with your species, it ain't going to happen. It's not, that works. But notice, in a lot of cases, they live in the same area, these species, but because they have different wired mating seasons, they're never going to encounter each other to mate. Like, for example, the eastern and western spotted skunk. You might think, man, they look really similar. But guess what? The eastern mates in late winter, doesn't mate in the summer. So the western mates in summer. So they're not going to mate outside their mating times because that is hardwired into their DNA. That's a behavioral thing. So they're not going to mate outside of their time. So guess what? They're reproductively isolated. If we force them together in a lab or something, or like force the sperm and egg together, we could make them reproduce, but in nature, they're not going to reproduce. 1 second, Joe. All right. I'm recording a video. 1 second. I'll call back. Ready? So if you're on the video, you got to see me answer Ms. Hart. Isn't that fun? So back to what I was saying. So another form of sympatric isolation, behavioral isolation. I'm sorry, I'm laughing because I just was thinking about human behavior. But with behavioral isolation, you have unique behavior patterns and rituals that isolate a species, okay? So they use these behaviors to identify who's in their species. And they want to attract mates of the same species. For example, they may do this through courtship rituals or mating calls. Because they have these specific things they do, they're not going to mate with an animal that can't do it in nature. It's like blue-footed boobies. I know, it's a weird name. They have this really weird courtship display and dance they do. And if a bird that, even if it looks similar to a blue-footed booby and the sperm and egg could work together, if you don't got the moves, it ain't happening. So those behaviors keep them from mating. So that is that way they never reproduce. So they are a separate species because in nature they won't reproduce. Last thing. So back like blue-footed boobies, there are ways to recognize your own species, and it's really strange how animals are. We think they're not as smart as us, but in reality, I know they're not like conscious or sentient like we are, as sentient as we are. But they're so interesting how specific they are, how smart they are. Like for example, this bug called the lacewing. They live in the same areas of there are a lot of different species of lacewings. They live in the same area. But if you look at these wave patterns here, literally each different species has a slightly different frequency and pattern to its courtship song that allows a species to recognize its type. Like the one at the bottom, the Johnsey one, its pattern is short bursts of a low frequency to a high frequency, and it's really like short controlled bursts. I'd say a little longer actually. But if you look at the top at the Floribunda, that dude has some speed bumps. Like it's like burp, burp, burp. So if the Johnsey hears the Floribunda, it's like, heck no, that ain't me. That ain't my thing. So fireflies, for example, they have courtship displays like the blue-footed booby. In nature, if you don't got the moves, it ain't happening. So they won't mate together in nature. Or the gray crown cranes in Kenya, they have this really weird. A lot of birds have really weird courtship displays. Once again, you don't got the moves, it ain't happening in nature. But once again, in a controlled setting, we could probably make two birds mate that usually don't in nature. But all of this happens in nature. Keep that in mind. So that is the concept of speciation. It's where two groups of organisms that get separated somehow, either by a geographic barrier or some other barrier like a behavior or a physical barrier, they over time evolve separately and they become different enough to where they won't interbreed anymore and they become two different species. Remember, this is in nature. In nature, if two species will not mate of their own accord or there is a barrier, they are probably different species. I hope this helps y'all if you're absent. And if you have any questions, shoot me an email. Hope y'all have a great day.